Now you got natural numbers. You've got, whole numbers. Then you've got integers. That's added to the realm, right? And then you've got what? Rational numbers, integers. And you have to write this down. This is just kind of help you guys see where we're headed. And then we have irrational numbers. Irrational numbers would be a number like, say, the square root of 2, right? And irrational numbers kind of sit off by themselves. Their irrational numbers are not rational. They're not integers. They're not whole numbers. They're not natural numbers. And then we have this other set that we call imaginary. Now, the fact is that all of these are what we call real. They're all real. But then we have this imaginary, and together, this whole group makes the set of what we call complex numbers. Okay? So it's just all these different kind of, groups of things that we talk about relating together. And a complex number is something that is written of the form a plus bi, where that is imaginary, and this is real. And so today we are going to express complex numbers in what we call that standard form. Now you can't ask me why. You just have to trust that it is the way it's defined. The square root of -1 we say is I. And I squared is -1. Now I can't tell you why we make that statement so much as I could tell you how we came up with it. If you say x squared minus 1 is equal to 0, how many solutions are there to that polynomial? 2. You look at the degree, you say there's 2 solutions, and that's going to be plus or minus 1. Now, if I say x squared plus 1 is equal to 0, how many real numbers work for that? None. But algebra says we would like to state that it still has 2 solutions. The only way you could say it still has 2 solutions, like the previous one, is if you say that there are these things called imaginary numbers. And it was out of that necessity that was born this idea of, okay, the square root of -1 is then I. Now, here's my question to you. Do you remember at the beginning of the year how I told you one of the things that resulted from the study of imaginary numbers and how it helped us move forward as a society? We're using it right now. Has to do with the smartboard. Electricity. The fact is that alternating current electricity uses complex numbers in the theory of its development. The people who came up with this stuff about I, they were like, what good will ever come from imaginary numbers? We can't think of anything. But the fact is that alternating current electricity is helpful. You got your phone, right? Phone, alternating current or direct current? Direct current, because it operates off a battery. If we only had direct current, folks, you'd have a power station just to operate the school. But we have a power station that operates the entire city of Albert Lea. Big difference. So are imaginary numbers important? You better believe it. They really helped us out. Perform the indicated operations. Super easy. 4 plus 3i minus 6 plus 8i. All you do is you combine the real parts, you combine the imaginary parts. 4 minus 6 is -2. 3i plus 8i, 11i. How's that? See lots of smiles. -6 plus 5i. Ooh, we combine the real parts, combine the imaginary parts. 1 plus 3 is 4, and -6 is -2. -i and -i is -2i, and 5i is 3i. So, is it fair to say that everybody can add and subtract them? Okay. We can multiply them too. 7i times 4i is equal to 28i squared. I like to write the I squared. It helps people understand that I times I is -1, so this is -28. Next one will be negative 24I squared. And because I squared is negative 1, the final answer is 24. Negative 2I times negative I is going to be positive 2I squared, which is negative 2. 6I times negative 2I. Negative 12I cubed. When people see an I cubed, their mind starts to melt and they start to get frustrated. So write it as negative 12I squared times I. Yes, thank you, sorry. So if we have 12I squared times I, what is 12I squared? Negative 12. So this comes out to be negative 12I. Same thing, you could break up this negative I cubed into negative I times I squared. Does everybody agree that those mean the same thing? Well, what's I squared? So I get just I. What if you had a mean teacher and the teacher asked you to do I to the 122nd power? You walk out. Okay. Challenge accepted. What if the teacher made the problem super simple? And say, let's write it as I squared to a power. I to the 122nd is the same as I squared to what power? Is it 120th power or is it the 61st power? Or neither? Power to a power, what do? Multiply or add? Multiply. So what would you multiply 2 by to get 122? 61. So let's simplify that. What's I squared? We have negative 1 to the 61st power. If you take negative 1 and multiply it an odd number of times, it's going to produce a positive or a negative? A negative. So I to the 122nd power is negative 1. Please add these small two problems at the bottom. I've forgotten about these two, just assuming that we would know it and see it and understand it. The first one is not too bad, but square root of negative 25 is. Now, I want to be careful as we say it's 5i. You're absolutely right, but I want you to show you the process by which it happens. We first need to deal with the square root of negative 1, then we deal with the square root of 25. The square root of negative 1 is, and the square root of 25 is, so we get 5i. Everybody okay there? What? When we take the square root of a number, we only list the principal root. We list the positive root. If you had x squared is equal to 25, then you list both solutions because there are two. But we're just taking the square root of a real number, so we just list one. See the difference? Now, this one, square root of negative 2 times square root of negative 18. This is how you do not do it. Well, this is square root of 36, which is 6. Can't do it like that. I'll show you why. Would you agree that the square root of negative 2 is the same thing as the square root of negative 1 times the square root of 2? Square root of negative 18 is square root of negative 1 times square root of 18. We're all on the same page there? Well, what is the square root of negative 1? I, roots of 2 times I, roots of 18. What's I times I? I squared times square root of 2 times square root of 18 is the square root of 36. Let's simplify that. I squared is negative 1. Square root of 36 is. So you see, the first way we did it, we came up with 6. But the second way we did it, we came up with negative 6. it's very important that as you deal with square root of negative numbers, that you deal with the imaginary part. Okay? Got to consider that imaginary part. Now, I'm not, because I'm not going to try to trick you on that. I'm not going to. And this will take us to the end of our day. 3i times 2, 6i, minus 15i squared. What is negative 15i squared? Positive 15. So you write as 15 plus 6i. See if you can do the next two on your own. Did you get 5 for the first one? Did you get 25 minus 39i? Good. There's one thing I want to point out because it's going to help us as we move forward. Wasn't it nice when you multiply those together because the middle's canceled? That's because they're what we call conjugates. Remember? Conjugates are the same except the ending changes sign. And that helped the middle go away. And we're going to use that as we move forward. Last 4, we talk about dividing. Now, as we look at 4 over I, again, we want to write it in the form of a plus bi. And it's currently not written in that form. Anybody know how I'll get rid of having an I in the denominator? Multiply top and bottom by I, because I over I is 1. So in the numerator, I get 4i. What do you get in the denominator? And 4i over negative 1 is negative 4i. Sweet. Negative 3 over 2i. Multiply top and bottom by. A lot of people say 2i. 2i would be a little bit excessive. We just need to do I. We don't need to get rid of the 2 or anything. So I get negative 3i over 2i squared. So the denominator is what? Yep, 3i over negative 2. And here's where I start to lose some people, but please don't get too lost. This isn't that big of a deal. I could either write it as 3i over 2, or I could write it as 3 over 2i. These are the same. Does everybody see that? And that's important because, again, we want to write it of the form a plus bi. So when I look at this as it's written in the second way, I can see that b is 3 over 2. Because second semester I'll teach you how to like graph these and do all sorts of other crazy stuff with them. In fact, second semester I teach you how to find the cubed root of 1 minus I roots of 3. That means, like, what do you multiply by itself 3 times to get that? Which seems ridiculous, doesn't it? But I can teach you how to do that. Yeah. Josie, what's the square root of negative 1? I. What's the square root of I? Ashler. No idea, right? It has a square root. Super complicated to think about, but I'll teach you. All right, but not now. Last 2 problems. 3 over I plus 1. Shoot, I just can't multiply top and bottom by I, because if I do that, I get what? I get 3i over negative 1 plus I, right? Like if you multiply the I through the bottom, like now I have another I, right? You could keep on doing it. I mean, it could be like a fun game. Like, you're like, hey, let's get together tonight. Let's multiply through by some I's and see what happens. Yeah, sure. Just conjugate. God, it's almost like I tried to intentionally prepare you for that. 1 minus I over 1 minus I. I like the way Josie thinks. what do you get in the numerator? 3 minus 3i. In the denominator, I multiply them out. Logan, question? You are 100% correct. Speak up sooner next time. Joey make about 40 mistakes each day. The sooner you speak up, better keeps us on track. So now I multiply the bottoms, I times I, or -1. Do I have to figure out the inside, the middles? Because they cancel. And then I have 1 times -1 is -1. So we get 3i minus 3 over -2. That is currently not in the form of a plus bi, is it? So I'm going to write it in that form. Dividing by -2 is the same as multiplying by -1/2. Agreed? So I have -3 and plus 3i. As I distribute that -1/2 through, I have 3/2 minus 3/2 I. Now it's written in the form of a plus bi. What do you think? Okay, last example. You have the rest of the hour to work. You could actually finish your assignment during class. Or watch The Office. Multiply top and bottom by the conjugate. 5 minus 2i over 5 minus 2i. We'll do the top. 2 times 5, 10. 2 times -2i, -4i. Negative I times 5, -5i. Negative I times -2i plus 2i squared. Heard you say -2. You're absolutely right. But I'm going to take my time because I know I make mistakes when I do this stuff. So I'm going to try to make sure I get this one right. 5 times 5, 25. And then the middles go away, and I end up with -4i squared. Okay, I'll deal with the top. What does this positive 2i squared come out to be? Plus 10 is 8. Minus 9i over, what's 25 minus 4i squared? 29. Thank you. Or 1/29 times 8 minus 9i. Multiply that 1/29 through, and we get 8 over 29 minus 9 over 29i. That's it. Good with those imaginary numbers, complex numbers? Some of that should be reviewed, right? Logan, I make another mistake? Right here? Right here. Nope. Nope. Just 1/29. You thought since I moved out here, -1 power? It's the power. It's included in the 1/29. I'm just saying instead of dividing by 29, it's the same as multiplying by 1/29. Now, here's the deal, though, Logan. This is the way I always think of it. I think of just, let's just divide each part by 29. And that's how I always think of it, but seemed like a lot of people wanted to think of it like this instead. So sometimes I know people think of problems differently. So, okay, all right. Have a great turkey day.